Alright, let's now quickly write and validate the binary searching algorithm according to the pseudocode that we have written in the previous steps. So inside the searching folder, whatever I have created, let me just create a new file called binary searching.cpp. Here, let me just add the C++ boilerplate. Along with that, let me just include the vector as well that we will be using for passing an array of values. Okay, along with that, let me just define one more class called binary searching. Okay, and in this, let's just add the public method. So ultimately, remember that binary searching algorithm will only work if the array of values that we have been given sorted either in the ascending order or in the descending order. Specifically, in whatever the implementation that we are doing, we are writing the logic specific to the array in which all the values are sorted in the ascending order. We have been asked to search for a specific value. Okay, if at all that value is found in the array of values we have been given, we will return the specific index. If not, we will simply be returning -1. That's the reason why the return type of the function will be int, and let's name the function as binary searching. Okay, and what this function does, it will take the vector array of values and it will also take the value that needs to be searched in the given values. Now, okay, so the very first step is as part of the binary searching algorithm, what we will do, we will divide the array into two halves, right? In the two halves itself, we will try to calculate the middle, and if the middle is having the value that user has passed, we will immediately return the middle index. If not, we will limit the search span to either left part of the array or the right part of the array, such that we are reducing the number of iterations. For that, let me just define a couple of variables. Let's just define one variable called start and initialize it with 0, because we need to start the searching from 0th index. And let me define another variable called end. This is nothing but the very last index we have in the array, which is nothing but array dot size -1. Okay, now what we will do is we will define one more variable called middle, and in the beginning let's just initialize it with -1. Now what we will do is we will simply be running a loop as long as the start is less than or equal to end. In this case, there are still some unsearched values that we need to search for finding the value that user has passed. That is what this means. That means as long as start is less than end means end has never gone lower than the start value. If that is the case, we have searched all the values and there is no point of continuing the search anymore. That's the reason why at that point of time we just need to break out of the loop. That is what this condition stands for. Okay, now here what we will do is we will calculate the middle index. Middle index is nothing but start plus whatever the end we have divided by 2. That's all it is. Okay, now once we calculate the middle, what we will do, we will check if the value that user wants to search is available at this middle index. If so, we will return the middle index directly. If not, we will again, based on the nature of the value that is available at this middle index compared with the value that user has passed, we will limit our search range to either left part of the array or the right part of the array specific to the middle index that we have got. For that, first of all, let's just do, if at all the value at the middle index, if it is equal to the value that user has passed, okay, what we will do, we will simply return middle index itself, because we found the position where the value that user wants is available. So we immediately return middle index. If this is not the case, what we will do, else if, okay, else if there are two conditions, right? If the value at the middle index is matched with the value that user has passed, that is absolutely fine. We will return the middle index. If not, whatever the value that user has passed, it could be smaller than the middle indexed value or it could be greater than the value at the middle index. Now, if at all the value that user has passed, if it is greater than the value at the middle index, that means we've got the value at the middle and we have the value that user has passed, and the value that user has passed is greater than the value we have at the middle. That means the search range is on the right side of the middle index. That's the reason why in that case start I will update it with middle plus 1. Okay, if this is not the case, the other scenario is obviously whatever the value that user has passed is smaller than the middle value. In that case, the possible search range is on the left side of the middle index. That's the reason why here end I will update it to mid minus 1. Okay, that is what the binary searching implementation is. That's all. First of all, we will try to calculate the middle index. After that, we will compare the value at that middle index with the value that user has passed. If it matches, we will return. Otherwise, based on the nature of the value that user has passed and the value that is available at the middle index, we will limit our search range to either left part of the array or right part of the array, and the same logic gets repeated by calculating the middle on either on the left part of the array or right part of the array till we exhaust all the possible positions in the array of values that we have been given. Okay, now once we complete this while loop, if at all there is no position in the array that has the value that user has passed, that basically means that the value is not available, right? So outside this while loop, to represent that, we simply need to return minus 1. Okay, so that is something that we never forget. Okay, so this is the simple binary searching implementation. Remember that in the beginning also I mentioned whatever the array of values that we are getting, right, these values are sorted in the ascending order. Okay, if at all if the array of values are sorted in the descending order, we just need to interchange these two lines of codes. That means line number 19 should be moved to line number 17 and line number 17 should be moved to line number 19. Okay, because the nature of the values is continuously decreasing in the array of values that we have been given. Okay, so that is something to note down. Okay, anyway, now that we have completed the implementation of this, let's just try to call this binary searching function and validate it. For that, first let me just create a group of values that I want to pass. Remember, I have mentioned the array of values needs to be sorted in the ascending order strictly. Okay, once we have that, to call the binary searching function, we need to create the object of this binary searching class. So binary searching bs dot binary searching, let's just pass the array, and I also want to search the value 4. Okay, now let me just capture the return value int position equal to, and after that let me just print position. Okay, now let me just cross check the implementation. Yes, everything looks fine, and let's just execute. Okay, so right click, choose run code option, and value 4 is available at index 3. So that is the output that we have got on the console. Let's just say I want to search for the value minus 4. Minus 4 is not available, right? So if I choose, it should return minus 1. That's what we have got. Similarly, if I pass the value 8, the value 8 is available at 8. So index 7, right? So that's the output that I should be seeing on the console, which we have got. Okay, so that is the binary searching algorithm implementation. Okay, thanks for watching this one. I'll see you in the next searching algorithm implementation.